All right, let's talk about some problem areas. This is the best part. Like we were talking about earlier, scale and corrosion. That's why we feed a chemical, scale and corrosion inhibitor. Scaling tendencies come from their calcium, magnesium, iron, silica, whatever's in the water, typically well water. Not an issue for soft water programs. So typical Lake Michigan water, if you start cycling that up too high, that's when you get scale formation. Corrosion, big time from soft water programs. So if you're using straight soft water, not good on your metal surfaces. So I suggest putting in a stainless system. Not always possible, obviously, with chillers, but corrosion is a concern because once you lose metal, you can't put it back on. And then fouling. So we'll talk a lot about microbiological growth, different biocides moving forward, but fouling is an issue, especially in those chillers, which if they're not running all the time, flow is your friend, we'll get some pretty bad growth in there. So mold, fungus, algae, all under the same umbrella. So here, we'll show you this again. This is where typical issues happen. So in your chillers, you can get scaling or corrosion based on the type of water quality. So you'll see the tubes a lot of times need to be cleaned or brushed depending on whether you have that slight scale formation or if there is some corrosion. You'll see parts of the system inside the tubes. And then you can get fouling not only in the pan of the tower if you do have one, otherwise the sump down here. That's where you'll get a lot of microbiological issues, whether it be like a film or some algae growth on your fill. I don't know if anyone has seen that before. And on top of that, some corrosion. So.
Around some good show and tell corrosion inside of that elbow. Scale buildup in this one. More on this one.
Yeah. So scale, the reason why we worry about scale from a heat transfer, I don't know if you can imagine trying to get any heat transfer through something like this, but it definitely makes your pipe that much more difficult to transport heat. So. But, what?
Reduce the fluid volume.
Exactly. However, we do lean towards, like Jason said, we do lean towards a scaling index because you can take scale off. You can acid treat it for pretty cheap. Replacing a chiller, not cheap. So again, here's the picture that we were just talking about. Every cooling water treatment program has a scale and corrosion inhibitor blend, whether that be for whatever makeup water quality that you have, and a biocide. We prefer, as outlined by a lot of guidelines, whether that be Legionella specific or just guidelines in general, to do a dual biocide program. So where your oxidizer, whether it be a chlorine or bromine base, we'll get into a little bit later, with a slower working non-oxidizer, really is the best way to remediate Legionella and other waterborne pathogens. And then sometimes we'll use antifoulants, not as common. So scaling corrosion inhibitor blend, I won't bore you to death with the chemistry here, but it's a blend of polymers, sequestrants, dispersants, and corrosion inhibitors, typically yellow metal corrosion inhibitors. So they're specifically blended to handle various water qualities. So the one that we use on Lake Michigan, definitely different from one that we would use on like a soft water based program. Any of these you can feed with or without acid. Again, we use acid to reduce alkalinity, keep you within your guidelines. Again, soft water makeup has a corrosion control problem. Bleeding in some hardness is always the right way to go. So then there's ways to test for scaling corrosion inhibitors. So that's why you pay your water treatment people so much to come in and do some monitoring for you. You can do it remotely through the latest PTSA sensor. So on the other side, you'll see a panel if you want to take a look at the end of the day what a typical water treatment panel looks like. But that PTSA is a fluorescent tracer that we put in there. Not affected by temperature, it's not consumed by anything. So it really is the best way to test for your residual. Otherwise, you can run some polymer tests, some phosphonates, or molybdenum is actually a metal used not only to help with scale and corrosion control, but also that you can trace. So those are the typical tests that we'll run, or if your guys are running tests, those are typically, PTSA and molybdenum are the two main, otherwise organophosphonate. So then we feed proportional to makeup or bleed volume, or like PTSA, that's our direct measurement. So the beauty of that is we feed on concentration. There's no guess on how much you're putting in. Feeding off of makeup sometimes can get tricky. So microbiological control. Bacteria, mold, fungus, and algae. Those can inhibit heat transfer. So just like scale, it can line your tubes. Major problem, not only from a heat transfer and flow inhibition, but corrosion. So microbiologically induced corrosion is a big deal. And not only that, a health and safety issue. So I don't think any healthcare facilities present today. Either way, I think it's making its way towards commercial office buildings, but looking out for Legionella is going to be extremely important. So let's get into the two main groups of biocides are oxidizers. So those are quick kill. Typically we feed those as the main biocide, a chlorine or a bromine. Different oxidizing biocides work at different pHs. So higher pH, typically we're going to put you on a bromine-based program. Chlorine, obviously, a little higher in corrosion problems. Chlorine dioxide we use a little bit in cooling towers, depending on, like Jason said, like cow water as makeup that you're pulling off of whey. Right.
Go after it with chlorine dioxide.
Right.
We've got a few applications out there where we're using it.
So that works exponentially better than chlorine and bromine when you actually have a biofilm problem. So you may have, we may just be taking over a system that never treated before that may need to attack the biofilm first, and then you go in with a chlorine. But not typical. We see peroxide and peracetic acid, but they are options. We just outline them. You'll typically see these top two. And then we'll hit it with a non-oxidizing biocide, whether it be isothiazoline, glutaraldehyde, DBNPA, different amines. There's many more. Here's your bread and butter right here, again, based on pH. And these are much slower killing. Typically, you feed them, you hold the water in the tower for 30 minutes to an hour, make sure it is circulated, and then you'll dump. But those are fed in perfect tandem with the oxidizing biocides, so just on an alternating basis. So I would check that when you go back, whether you're working with us or someone else. Really, this is the best program outlined as an oxidizer coupled with a non-oxidizer. So biocides, a little different from cooling tower inhibitors. We feed dose based on system volume. So the size of the system, that's what we're treating. So different biocides, again, have different requirements. Retention time, like I said, quick versus slow killing. Some are meant to attack organics that come in from, whether it be dust, anything, if you're right by a freeway, right by a highway, or a cornfield, we have those issues too. Some work to penetrate that. And then requirements for effectiveness. You got to feed the right concentration and sufficient contact time. So those are just two things that all these will impact the efficacy of the biocide, but it's up to your water treatment people to kind of help push you in the right direction based on your water quality. And again, check for the dual biocide. We don't make up the rules just to sell more chemical. It really is the most efficient way, most effective way. So antifoulants, I'm not going to go over too much of this. It's not overly common, but if you have any oil and grease, some process contaminants that come back, like a die cast shop that maybe gets the dilute back into their towers, You'll feed that in a slug feed. It may cause foaming, but it also increases the effectiveness of biocides. So it does act as like a wetting agent. It helps you penetrate the biomass. And then defoamers, like we talked about, same reason for boilers. That can cause major issues introducing air into your system. But some biocides, when they're actually working, they foam. So when it's attacking whatever's in there, it'll foam a little bit. You may need them. It's not overly common. We typically use anti-foams when we're descaling because it is attacking the scale. But if you have a foaming problem, you probably have a greater problem than just biocides attacking. So here's some takeaways specifically. Know your water program. We're not gonna. You don't have to guess on what to do. We're gonna push you in the right direction. Know your pre-treatment equipment and make sure it's working, especially for boilers. Okay. Install makeup and blow down meters. We like to meter everything. A lot of times we can catch things before they happen because of meters. Not to mention you can maybe get some evaporation credits. So we find meter. Having an idea of how much water you're using versus going down the drain is extremely critical. Understand cycles of concentration, again outlined by your water treatment company and typically by the guidelines based on whatever your boiler manufacturer calls for or ASME guidelines. And then consider using automated systems to monitor, control, alarm, and trend water systems. Again, if you have the right water treatment vendor, they can catch problems before they happen because of this. So can't stress that last point enough. And again, on the other side is just a little rundown of what our panels typically look like. It may look a little different from what you have, but that's pretty basic. So I don't know if anyone had any questions about this stuff specifically.